Recording in progress.
This video covers the review of section 6 and 7 in chapter 4. We're talking about absolute value equations and inequalities and what those look like in the process we go through in order to solve them. So there's just a couple of things we need to know about the inequalities that are a little bit different. So I'm going to do these a little bit out of order. I just want to make sure that I keep it focused on what we do with equations and what we do with inequalities. Okay, so number 2 and number 3 are both equations. So with number 2, we know that the absolute value of any number must always be positive, even though that number, like W, certainly could be a negative number, but when we find the absolute value of it, it's always a positive number. Therefore, if everything on one side of the equal sign is inside of the absolute value and everything outside of it on the other side, it will never equal a negative number. So this is an example of where we have a null set. So an absolute value will always equal a positive number. Okay. Now, in the case of, so that's pretty much it. That's the point of that entire problem. For number 3, this one is an example of where we do have something outside of our absolute value. And so whenever that happens, whether it's an equation or an inequality, you've got to move that to the other side. So we need to use our, oh goodness here, our addition property of equality and move that positive 3 over so that we end up with the absolute value of 12x minus 8 is equal to 12. Oh, yeah, this looks familiar. All right, once we have that, now we can write our 2 equations. So our first one is 12x is just a copy of the inequality equation. 12x minus 8 is equal to 12. And then the other one is 12x minus 8 is equal to negative 12. So again, the 12x minus 8, that's our origin, or the difference between our origin and x. And so we either go up, and the 12 is the distance. So we either go up the number line 12 or we go down the number line 12. So that's why it equals a positive 12 or a negative 12. All right, and then we just solve. So I'm going to add 8 to both sides. I get 12x equals 20. And then I divide by 12. And x equals 5 over 4. Right? No, 5/30. 5 over, let's see, 4 goes into 20. 5 times 5 over 3. Okay. Excuse me. So 5/3 or 1 and 2/3. Okay. And then the other one is we add 8 to both sides. So I get 12x equals, that's negative 12 plus 8. So it's negative 4. They're unlike signs, and my internet is starting to get really bad, so it's looking wonky. Divide by 12. I get x equals negative 1/3. So x is negative 1/3 or 5/3. Let's see. Okay, and I've got one more. So for number 6 here, I've got one more equation. So again, this one, all the absolute values on one side and the real number is on the other side, and it's positive. Got to be positive. So we just write our 2 equations. 9w minus 7 equals 25, and 9w minus 7 equals negative 25. So this one we add 7 to both sides. I get 9w equals 32. Divide by 9, and we get w equals 32 divided by 9. And then our other value for w, we add 7. get 9w equals negative 18. Divide by 9, w equals negative 2. So w equals negative 2 and or 32/9. There's our answer. Okay, so when we are solving inequalities, we have to do something a little bit different. First, if you have an inequality that is an absolute value greater than 12, you are looking at a disjunction, an or statement. So when we graph those, they're always going to start some distance from the origin and go either down the number line or up the number line. So there's never going to be a number that's going to be the same for both because they are always greater. The distance from the origin is always greater than, come on, either this or this. Okay, so in this case, but you still write your two separate. So this is x plus 9 is greater than 12, or x plus 9, and then we always flip the inequality when we make the distance negative. And then we just solve. So subtract 9, and we get x is greater than 3, or subtract 9, x must be less than negative, what is that, 21? All right, and you cannot write these as combined statements because they're disjunctions. So that's pretty much it. X is greater than 3 or less than 21. We'll just leave it like that. All right, let's look at another one. So for number 4, we have a less than. So again, this is the example where if you have some origin and the distance from that origin must be less than some given calculated distance. And so it's only going to go either up or down the number line, that distance, whatever you calculate. And so looking at these, remember this is your distance. We'll get to that when we get down to the problems at the bottom. Okay, so this is an and statement. Get my internet to maybe work. And it's a conjunction. So this is 4x plus 5 is less than or equal to 14, and 4x plus 5 is greater than and equal to negative 14. All right, so solve them individually. Subtract 5 from both sides. Get 4x is less than or equal to 9. Divide by 4. And x is less than or equal to 9/4. And if we subtract 5 from both, that 4x is greater than or equal to negative 19. 4x is greater than or equal to negative 19/4, which makes sense, right? X needs to be greater than the smallest number, the negative in this case, but it needs to be less than the positive, the 9/4. This we can write as a combined statement if will let me. So x greater than or equal to, less than or equal to 9/4, greater than or equal to negative 19/4. Okay, let's look at this last one here. Okay, so for number 5, we do have this plus 8 outside of our absolute value, so we've got to move that first. So if we move that over here, then we get the absolute value of 8/5 y minus 2 is less than negative 2. So that means that the absolute value of some number is less than a negative number. That cannot be possible. So this is another example of a null set with an inequality statement. So again, an absolute value cannot, so a distance cannot be less than 0. So that's a null set. So again, this is why it's so important that you move anything that is outside of your absolute value before you evaluate what you're looking at. You cannot keep it like it is with the absolute value plus 8 less than 6 as two separate equations and then try to write it as two separate equations. You're not going to get a valid answer. Okay, so now let's look at this last part here. So write an equation representing all numbers that are 15 units from 5. So this is where I was talking to you guys that the formula for distance, and I'm just going to write it as distance equals, I think I've been writing as distance equals x minus k, where d is distance and k is midpoint or the origin. So this is the origin, and this is the distance. And this is important because it always includes a subtraction. It's always the difference between 2 points. So that way, if your origin is negative, then in the absolute value, it's going to look like a plus because you're subtracting a negative number, which simplifies to a positive. But I'll show you what I'm talking about here. So when we look at 15 units from 5, well, 5, this is my starting point. This is my origin. 15 units, this is my distance from that origin. Whenever you're breaking these down, it tells you how you know which number goes where. So if distance is 15, then that means I'm going to kind of flip this around. So absolute value is on one side. And if we're just writing equations, we're not solving them for these. I don't believe, although it is still under a solve. Yeah, we'll do both. We could use the practice. Okay, so this is the absolute value of x minus k, my origin, which in this case is a positive 5, so I'm subtracting 5, equals my distance, which is 15. So there's my equation. Now let's solve it. So this means that x minus 5 equals 15, and, or it doesn't really matter, or x minus 5 is negative 15. So when we solve it, we add 5 to both sides, and we get x equals 20, or if we go up the number line, or x equals, so add 10, go down the number line. So that's the second part, x negative 10. So those are the two values that are 15 from 5, our origin. All right, so let's look at the second one. Write an equation representing all numbers that are 7 units from negative 3. So this is an example of where our origin is a negative number. So if we use our original formula, this is the absolute value of x minus our origin, which is negative 3, is equal to our distance, which is 7. So this is where the plus comes in. So this is x plus 3, absolute value of x plus 3 equals 7. So there's the first part, our equation. So now let's solve it. We have x plus 3 equals 7, or we have x plus 3 equals negative 7. Subtract 3 from both sides, and we get x equals 4. Or in the other direction, that endpoint is at x equals 2 points that are 7 units from the origin of -3 is 4 and -10. 10. All right, so now let's look at writing inequalities. Same process. You still have the absolute value of x minus some number. And then this is where we have to be careful what our symbol is. And then we have our distance. So we have at most 8 units from 2. All right, so we know that our midpoint is, our origin, excuse me, is 2. And we know that our distance is 8. So it's telling us that we want all the numbers that are at most 8 units from 2. So we do have an equals to, but that means that they all have to be less than or equal to 8. So that's where we have to be really careful about which inequality symbol we use. So now that we have that, we can go ahead and that's part of our solution, or what we're being asked to find. So now let's solve it. I have x minus 2 is less than or equal to 8. And this is a conjunction, so it's an and statement. X minus 2 is greater than or equal to -8. So we add 2 to both sides. Is less than or equal to 10. And here must be greater than or equal to -6. So x greater than or equal to -6, less than or equal to 10. There's our solution set. All right, the next one is at least 3 units from -5. So x minus our origin, which is -5, and at least means it must be greater than or equal to a distance of 3. All right, so I'm going to simplify this. I get x plus 5 inside absolute value greater than or equal to 3. Now this one is a disjunction, so we can't write a combined statement, but this is x plus 5 is greater than or equal to 3, or x plus 5 less than or equal to -3. Greater than or equal to -2. Subtract 5 here. X is greater than or equal to, less than or equal to -8. So we have our range of values for x to give us a true statement. I believe that covers it. Yep, that's everything that we have. This was the review guide for section 4.7, 4.8, and it covers everything that you're going to need to know for those. So the important part is just to know this here, like from the written form, what is your distance? Where does your distance go? Where does your origin go? How do we put all that together when we take the written problem, word problems, and turn them into absolute value equations or inequalities? All right, that should cover it. Thank you so much.